Welcome to Tech Rabbit. Today we will talk about the SVM, that is support vector machine algorithm. Agenda for SVM is its definition, types, terminologies, how it works, advantages, disadvantages, and its applications. So what is SVM? It is a support vector machine. It is supervised learning algorithm which helps in classification, regression, and outlier detection. How it works? It creates a hyperplane that maximally suppresses the classes. So let's say we have a 2D plane where the points are red and green. This can be divided into by a hyperplane, and a hyperplane is such that it has the maximum distance between the two points of this red and green. I will explain you in the next slide how it defines the hyperplane. In 3D you will find a plane that divides the classes. Next we will move to types of SVM. There are two types of SVM. One is linear and another is non-linear. Linear has a data separable, and in linear it is not separable. Here in non-linear we will use a kernel trick to map the data for classification. In these slides we will cover only linear types of SVM. So coming to SVM terminologies, we will have two classes. We divide these classes by using hyperplane, and this is we call the maximum margin hyperplane. There are different kinds of hyperplane possibility here, but we will select this only one plane. I will explain one in the next slides. So this plane intersect this blue point and a green point, and this is called a support vectors. Okay, so let's look at how SVM works. So let's say we have a coordinate system x and y. We have where we have having two classes. So there are different kinds of hyperplane possibility. We can draw it here like this. We can draw it here like this. Multiple possibilities. Also we can draw it like this. But which one is the best one? So which hyperplane we should select? So we will select hyperplane which having a maximum distance between the two categories. So let's say we have a hyperplane A, okay, where it can divide two classes, and this is the width of the width of the support vectors. Okay, we will call it the width, and let's say this is the one. Then we will divide again. We will take the next hyperplane B, and this is the width of support vector B, and then this is a C. If you look at here, the width of C have SVM support vector is maximum as compared to these two. So hence we will select C. So C is the winner here. So we will take C for classification, and we will take weights of this. We will take the weight of this hyperplane. So SVM terminologies, there are we will call as W as the weights, X is input, and Y is the output. There are only two categories, like we are taking only -1 and 1. So for classification, this is the equation for hyperplane and positive and negative hyperplanes. Okay, if it's equal to 0, then it is hyperplane. Okay, once we will find out the hyperplane, we will look at the terminologies, how it is differ from in coordinate system. So this is the B, like a B divided by square root of W1 by W2 square. So this is how from the 0 0 coordinate system how it map into the coordinate system. The second is the width of the support vector, that is 2 by square root of W1 square plus W2 square. And third is we will find out, like, this is the points. With this equation we can get this one side of the hyperplane, and with this the second equation we will get the other side of hyperplane. So this is how we will divide the classes into two categories with the help of support vector. What are the advantages? It is high dimensional spaces. It is effective in high dimensional spaces, and also it works in linear and non-linear problem. It is SVM is a memory efficient because it takes input from trained dataset and apply into the test one. Okay, it is robust in noise, and similarly we will have also have disadvantages for the SVM. That is, it is computationally intensive. It is sensitive to the choice of the kernel also, and we can't use it for the large datasets. Applications of SVMs are image classifications, text classification, handwriting recognition, bioinformatics, and fraud detection. So this is about its applications. So moving to the last slide, so we will go to that SVM again. So this is SVM is a support vector machine, and it is supervised machine algorithm for the classification method. So this is we will divide the classes into two category with the help of hyperplane. We will divide the hyperplane such that we will have a maximum weights. Okay, so this is a weight of the SVM uh, technique behind this support vector machines. Okay, I hope you like this video. Please like and subscribe to my channel. Thank you.